Hey there, I'm srcmake and welcome to the tutorial on continuous integration and continuous deployment using GitLab. And this is going to be an easy introduction video where we are going to just talk about what continuous integration and continuous deployment are. And we're going to look at how you can do this on GitLab because GitLab has this feature set up, and we're just going to set it up and have a really baby project just to get it running and make sure we can do it ourselves. And in future videos, we're going to make the process more automated. We're going to have a lot more tests running, and it's going to be a lot more streamlined for bigger projects in the future, in future videos. So as usual, I've got all the resources that we need right here on my website. Go ahead and click the link below the video to get to this webpage if you want to follow along. And while you're down there, hit the subscribe button for this YouTube channel. Thanks. So let's get started. Why use continuous integration and continuous deployment? Well, for most major code projects, there are a few things that happen. First of all, code has to be written, and that code has to be compiled or built into an application usually. Sometimes you have server code that just lives on the server, but sometimes you have an app or, a desktop application that needs to be packaged together and compiled. And of course, the code and the application itself has to be tested. There could be multiple phases of testing. Maybe one piece of code needs to run a unit test on that to make sure the library works. Maybe the whole application needs to make sure that, one field works and errors don't happen. All sorts of testing occur. And then if the code is deemed acceptable, then it has to be usually deployed somewhere, like maybe to an app store, maybe just to the server where the website is running. Code has to be deployed somewhere. It doesn't just sit on our developer computer, right? So this seems like a lot. It seems like an easy list to manage for each project, but it's actually really tricky because for three reasons. One, there could be multiple people working on the same project. Like maybe I write a piece of code and someone else writes a piece of code, but and a whole bunch of other people write code, but it all has to come together to one project, right? And that's like sort of an issue because in the old days, there would be like one person who make sure that one person's code works when they add it to the master branch. Then they make sure someone else's code works when they add it to the master branch and stuff like that. But now, I can just be at my computer. Well, we'll get into that in a sec. The other reason why this might not be easy because everyone has different developer environments. So maybe I'm running Ubuntu 16 Linux, which I usually do. Maybe someone else uses a Mac laptop. Maybe someone else uses Windows. Since everyone has different setups and they're all still working on the same project, it's good to have like one place where we all know that the libraries work and exist, because maybe my computer has a little bit of a different setup than yours, but that's why the project works on mine, but it's a little different on yours. It's good to have this automated, and not just automated, but standard for the project. And lastly, it takes time to verify that the tests work. So let's say that I write a piece of code and then I have to test it, right? Usually, personally, I would have to test it, and I'd have to say, okay, I need to compile this project to see if it works. Then I need to run all these tests, and each individual developer has to spend time doing that before they can really move on. But instead of that, continuous integration really helps us and saves the day. So most of the time, literally almost all the time, our code is hosted on a code repository like GitHub or GitLab. And what this means is that the code is just it's versioned, right? You have the project, and there may be multiple branches depending on the project, and commits are saved. Basically, I write a bit of code, I like it, so I push it to the repository to be saved. And this creates a new version of the code. And code keeps building up like that until the project gets bigger and bigger. And we have this versioning system, so why don't we what continuous integration does is every time a new commit is made, and if you don't know about Git, there's other tutorials on the website that you can use, but when a version is made for, let's say I push code to the repository, continuous integration will say, okay, with GitLab particularly, GitLab will have a Docker file running for this commit. So my code will get pushed to the repository, and a Docker image will basically spin up a virtual machine, and it can do anything that's specified that's necessary for the project. So let's say we're building, a let's say just some Java application. What needs to be done every time a commit happens or anytime a new piece of code is added is the code has to build using Maven or Gradle or something like that, and it has to make sure that it works. So that's the whole long process. Then the code has to actually be tested, like running unit tests, which actually might even happen before the compilation. Like make sure that this individual file and its unit tests work together before even trying to compile. So unit tests, then compiling, then making sure that the application itself does what is expected of it. So that's another set of tests that aren't just code tests. So there's a bunch that needs to happen anytime a piece of code is added to the project. And what GitLab does is they have continuous integration where you can specify a Docker file, and that Docker file is basically a virtual machine. And that virtual machine you can specify in what's called a .gitlab ci.yaml file, basically a configuration file, a manifest file that specifies the test or whatever needs to be done whenever the project happens. And you're going to see the example that we do. So basically, continuous integration is anytime code is committed to a code repository, you have an automated script that either builds it or deploys it, tests it, whatever you need to do. Continuous deployment actually is the deployment phase. That's where you say, okay, all the tests are passed, so push it to a website. And that's one thing I didn't mention that I should have mentioned. What happens if the code fails? What happens? Well, you can configure it to whatever you want, and we'll be doing that in future videos. But basically, if the code passes, you can do something. If the code fails, you can send error messages to the team, you can email people, you can send it on Slack, you can do whatever you want. And because it's so open-ended, it doesn't make sense to just talk about it now. What we're going to do in this video is just look at how it works. And then I'll explain as we're doing it how all the parts work. And then in the future, we're going to make our whole process like a lot better, like bigger and more efficient. Not more efficient, more complicated for bigger projects. So I'm going to open my 1.2.16 virtual machine right now. And it's running right now. I've got the web page open, and I've got a project folder. So what we're going to do right now is we are going to make a starter project on GitLab, and we're going to test the continuous integration out. So we're just going to make sure that you'll see the project when we do it. So what we need to do first is create a project on GitLab. If you don't have a GitLab account, register for one. But otherwise, I'm just going to create it right now. And I'm going to make this, let's call it srcmake CII for some reason, because actually, you know what? Let's just name it srcmake CII. And we're going to make it public, and we're just going to create the project. And you can see that GitLab will create the repository for us. Nothing amazing. If you don't know GitLab, this is just how it works. And what we want to do is we have some code that we want to test. So I've set up some code on GitHub, ironically, that is going to be our sample project. And a big shout out to Olin Data, because if you look at the references, I just want to, give them their props. They basically made this sample project. I watched this YouTube video when I was actually learning about the topic. So just a shout out to them. If my explanation isn't clear, maybe you can go to them, watch this video. So yeah, we have a sample project that we want to continuously integrate. And this is a sample project. So we're going to clone it in our repository, and the command for that is like right here. You can just copy and paste this. So I'll just copy the URL from right here. And this is our local folder, on our computer for the project. And I'm just going to cd into it. And we're going to open the terminal here. And let's look at the project itself to see what it is comprised of. So there's a README file, no big deal. Our project is a simple Hello World C++ program. So let's open it and look inside. It is literally just a C++ program, Hello World. It is going to output Hello World to the console, and it is going to return 0. Int main is going to return 0. Now, the other thing we have that, again, Olin Data, I got to give them their props for making this, is a simple unit test called verify.sh. It's a shell command. It's a bash script, and it's going to run Hello World, an executable file named Hello World, and it's going to check that the return value is 0, and it's going to check that the output is Hello World. Great. So that's the verify.sh file. That's just our unit test. So again, what we want to do for this is we want to upload this to, what we're going to do is we're going to upload this to GitLab, this project, and we want it to continuously integrate. And in this case, we're just going to start out really small. We just want to make sure, we're going to run this verify.sh file, and we're going to manually check that it's working. Just to start out. Again, this isn't really that useful, but we're going to expand upon it in future videos. So before we do that, I want to, let's do some cool hacker stuff. Let's do ls/al, which is going to list every file in the directory. So we've got a .git folder, which is just going to, it has that good stuff. But we have this GitLab ci.yaml file, which is a little special. So why don't we, can we cat it? I don't even know. I mean, not if it's possible. It's obviously possible. Will it look good? Okay, great. This is perfect. So we've got this .gitlab ci.yaml file. And this file in the project is what specifies what GitLab should do when to actually handle this automation. So again, we are going to push this project continuously, like continuous integration. We're going to push it to GitLab. And every time this code gets pushed to GitLab, every time it sees a new commit, GitLab is going to see this file and it's going to say, oh, all right, this file exists. So I guess they want us to run continuous integration. So, okay, let's do the continuous integration for this project. And whatever they want to do is going to be defined inside of this .yaml file. So again, this file is the manifest file that tells GitLab that we want to do continuous integration. And what are we going to do for the continuous integration? Well, all of that is specified inside of this file. So that's the magic, that this file exists, GitLab's smart and it knows, and then it's going to do whatever is defined inside. So what's inside of it? The first thing we see is that the image that we're going to choose is an Ubuntu 14.04 image. We're just going to use Ubuntu as our Docker image. Next, we are going to run a couple of commands, sudo apt-get update. Actually, it's just apt-get update. And then we have apt-get install gcc g++, which is just a C++ compiler. Obviously, we need to compile a C++ code, and that doesn't come out of the box. You need to install the compiler. And then we have a couple of scripts that we're going to run. The first script is going to compile our C++ code into an executable file named hello world. That's what this line does. And then we are going to run verify.sh, which is the bash script, just to make sure it's going to run, and it's just going to output whether, is it going to output? Let's see, what does it do? It's just going to output whether it works or not. So yeah. And then we have the last thing is this artifacts specification, and that just says which files are going to persist after the continuous integration. So some things might, it's just an image that's going to get deleted afterward, but this artifacts will be able to save files just in case, we want to keep logs, keep track of something, or something fails, so we want to download it later to manually inspect it on our computer. We can do that with the artifacts. So very basic .yaml file just for the continuous integration. So I close that. I don't know why. Let's git push, and what we're going to do is we're going to push it to our project folder. And I'm going to specify the URL. So we're pushing it to this URL, and GitLab is asking me for my credentials, which are, okay, perfect. And yeah, that's it. So now if you look right here and refresh the page, instead of seeing a blank project, our code is uploaded here. Perfect. And of course, GitLab is going to see that, oh, these guys, they just pushed this .gitlab/ci.yaml file. So if you expand this a little, you'll see that there's a ci/cd section. And if you look at jobs, you can see that our continuous integration job is running. Now, I'll say this right now. We didn't do anything special, right? You saw me create the project, and GitLab, they just automatically did this for free. It's not like I have a special account. So honestly, I want to shout out GitLab because they're really cool. I personally, and you can see that the job is running right now. You can read it, but GitLab's really cool. I read an article on them, and they seem to be really good guys. They could be making a ton of money, but they're making a lot of this free and so easy to work with. So I used to be a person who was like, all right, I'm just going to deal with GitHub. I don't like GitLab. But I saw GitLab being used in some projects, and this continuous integration is such a nice feature. And what it's doing right now is GitLab has a bunch of what's called shared runners. So a runner is a basically virtual machine that GitLab has for the community. They have a bunch of them, a bunch of servers that spin up these Docker images anytime someone does a continuous integration, so it can run the job. So again, we don't have these servers ourselves. This is like GitLab running on GitLab servers. They're really nice to us. And you'll see that one of the things we're going to improve on in the future is we are going to set up our own specific servers on our own computers, because let's say we're a big company, and we have a bunch of people committing code, and we just need the space right now. We don't have time to wait for other people. So we could actually set up our own server with GitLab to actually be running our jobs. That's one thing we'll do in the future. But you can see that it's running apt-get update, and now it's installing GCC. Again, this is just like a Linux shell, which is honestly really cool. I like this a lot. So just to reiterate the process one more time, I had this code on GitHub with the sample project, and it's good because just a simple C++ hello world, and we've got this verify.sh file. And, the other thing we have is this YAML file, and that specifies that, okay, it tells GitLab that we want to run continuous integration. And not only that, it also specifies the actual content that, is going to run, because you can see we run our script. So we can see that .verify.sh return value is 0 and the output is correct. Great. So we would manually inspect this, and the job succeeded. Everything's done. This job succeeded isn't, it doesn't care about this output. It only cares that there was no error or anything like that. And of course, we uploaded the hello world executable file because that's what we specified in the YAML file. So we could actually download it like right here if we wanted to, which I did. So that's GitLab CI. That's it. That's all you have to do. It's so magic, isn't it? We barely did anything. We just copied some code and pushed it to GitLab. And I'm going to end this video by saying what we could do next. So again, this was just like a basic introduction, and it takes a lot of work, depending on your project's needs, setting it up the way you need to, for all the tests you need to run, for all the building you need to do, and anything like that. So let's look over just what improvements we're going to make in future videos. So what we could do is we could install some common things. For example, Postgres is a database that is commonly included and necessary in these Docker images. So instead of installing it with Linux like this, with just simple sudo apt-get installs, we could just, GitLab makes it easy by having an image that already has it pre-installed, which saves us time. It saves us a lot of time, which is important. So you might have to do that depending on your needs, see what's already out there. Next, as I already said, set up a specific runner or server instead of just using GitLab's free shared runners in case your project is big. Shared is great and it's really easy, but if you really have a big team and you need your code like quickly, then just got to do it. Because, if there's like 10 people on the project and there's only one project GitLab repository, then I think it only has like one shared runner. Don't quote me on that, but if me and Susie on the team commit at the same time, we're both going to be waiting depending on GitLab's resources. Next, we could make more complicated building procedures. We only had one simple C++ file, but if it was like a Java project with Maven, it would have been complicated. We could have more complicated testing procedures. We just manually inspected this, but we could have more testing. You could do 3 and 4 in separate steps, test something, build something, test something else, build something else. You could make it as complicated as you want. And of course, that's just, getting to learn how to make this .yaml file better. Next, we could set up messaging to occur if something fails. So right now, if this failed, we'd have to manually look at it to make sure. But you could send a message just, with details. You could set it up as detailed as you want, as much time as you want to spend setting that up in case something fails. Like, oh, this unit test failed, so let me email this person. Whatever you need to do. And next, last thing is we could set up continuous deployment. So, okay, if everything passes, let's actually push this code to our server for the website on AWS or Heroku or something like that. You could set that up too. So that is continuous integration using GitLab. I hope I didn't take too long, but that's really easy. I thought it was really easy. And this was a baby video. In future videos, we are going to be doing more complicated stuff, the stuff we just talked about to make things better. So go ahead and hit the subscribe button to keep stay in tune with stuff like this. To learn more about this topic. And in the future, I'll be doing other topics too, which is, really great. So do subscribe. I'm srcmake. Thanks for watching.